Yeah, it's recording. Okay, let's start then. Yeah, hello everyone and welcome to today's session. Thank you so much for joining. Happy New Year to all of you. May this year bring new happiness, new goals, new achievements, and many more new aspirations to our life. Well, let's as we are stepping into in 2021, it's important to take the new learning and better understanding. There have been very many learnings that we got from the year in 2020, like safeguarding our health, being supportive to each other, spreading kindness. And now let's try to utilize this platform as a learning session only. So welcome everyone. We will have a short question answer session also at the end of the webinar. But let's start the journey. So I will present it. 1 second. So welcome on the webinar of and configuration of RAN. Lot of people have joined today, I'm seeing. So I just want to brief them that we, Aarna, got the 10 coolest edge computing startup of 2020 by CRN. And let me present today Vivek, who is going to show us the demo. Vivek has got over 20 years of experience in networking and storage, and he has been involved in ONAP since the first release in Amsterdam. Thank you, Vivek, for giving us an awareness session today. Over to you, Vivek.
Thanks, Priya. So can you stop sharing so
yes,
I can?
I will do that. Yeah, Vivek.
Yeah, just give me a minute and I'm going to share my screen. So can everyone see my screen? Is it clear?
I can see.
Okay. So good morning, everyone. And I guess Priya did give an introduction about me. So I've been involved with ONAP since the first release, Amsterdam. And today we will be, sharing some of the experiences that we went through with some O-RAN related activities that we did using some of the components in ONAP and then AMCOP, which is our own distribution. So we would like to share some of the work that we did it with the community. So basically to make you understand what we did, this is all about the webinar. And if you have any questions, feel free to stop me in between the presentation. Otherwise, I would recommend, let's have the Q&A at the end because I have a flow planned. So it's going to be a very short session. So maybe 30 to 40 minutes, I would say, not more than that. And 10 minutes of, within that, we will have around 10 minutes of a demo that I will walk you through the steps, what we did to achieve a day-in configuration of a O-RAN device. So here, when we say about RAN device, it's not actual O-RAN device, it's a simulator that we used. Okay, let's get started. So what are the goals for this webinar? So we'll talk about just briefly, show you a high-level picture, the overview about the AMCOP, our product architecture, and then AMCOP LCM architecture that I will walk you through a little more detail than the overall architecture. And then AMCOP O-RAN device integration flow, what we did, what are we going to show as part of this webinar is an objective that I'll make you understand. And then network topology simulator O-RAN simulator project that I wanted to give some introduction because we will not talk too much on this, but we did use this project. What I mean is we extended this project to create our O-RAN device to expose O-RANInterfaces. So that's what we did it. So we wanted to share that project. Then we will review one of the CDS model for a 3GPP NRM model, how to manage a certain O-RAN device. That I will walk you through that. And we will have a demo followed by Q&A. All right. Okay. So this is a AMCOP architecture. And if you see that the bottom side of it is like, You can have CNCF infrastructure running anywhere, on premises or hybrid or over your cloud infrastructure. That's where you're going to deploy all your 5G core CNFs. So that's how it's going to be, or your RAN devices. And within our AMCOP distribution, we have MCO, that's a cloud manager interface. And then we have Aarna lifecycle manager, LM, so which is core component, which interacts with our workflow engine. And the workflow engine capabilities are exported as a inbound or northbound API for OSS or BSS through either you can consume it as our UI, or you can directly invoke our REST APIs to integrate your existing OSS and BSS. And we do have an analytics platform, which we call it as an AAP, which comes with NRRIC and DAF platform included, which is just an overall view, and we will not discuss too much on this component. So let's go to the LCM, because that's what the component that we will be focusing it for today. So what is this AMCOP lifecycle management architecture? So we have, it's basically built out of, the core component of ONAMP is the CDS, the Controller Design Studio platform. So we took this platform and then we added certain capabilities to from our UI and our orchestration engine. Plus, we have our analytics platform which interacts with CDS. So why? Because all the NCM operations, we rely on CDS to push the configuration changes to all the southbound interfaces. Netconf, Ansible, REST, gRPC, could be a CLI or SSH, or executing a Python script. SOAP is something that we are considering, because we need to extend the CDS image to support this library. But WSL is already supported, so we have not tested it. So we marked it as not applicable as the southbound. Again, why CDS? Because it's again model driven, day zero or day in configuration changes. When I say model driven, it's just not that AMCOP UI or our platform. Anybody can consume this model to integrate their existing workflow engine or their OSS or BSS system to push day in configuration changes. And this is one of the primary interface for our analytics as well as the LCM components, and with rollback capabilities. So that's very important, because if your day in configuration involves multiple actions, if one of the action fails, we have the capability to roll it back. And it again abstracts all the southbound interfaces at REST API calls. You don't need to actually talk to these devices using different protocols. Rather, you expose the northbound as a simple REST API interfaces. And we have Kotlin and Python language binding supports for every CB. So we prefer Kotlin because it makes our LCM platform very lightweight, actually, because if you look at the CDS as a platform, we kept a lot of these components like command executor, Python executor, SCC listener, CDS UI. A lot of this optional for us, because we don't need the entire CDS platform. We can simply take the blueprint processor as an engine, which has got a built-in support for Kotlin scripts. So that's why we took it as a very lightweight platform. We sliced it off, and then we created a very lightweight version of CDS. So what is that we are going to demonstrate it in this integration is like, we have AMCOP, which like to push a day in config changes for our own interface for an ORRM policy ratio. So when I say ORRM policy ratio, we would like to add some policies, reduced resource management policy on the through own interface on a 3GPP simulator CNF. That's what we wanted to demonstrate. It's a very simple demo. So AMCOP will push a day in configuration changes to target CNF, which is deployed on a target K8s cluster. What we will not be covering is orchestrating the CNF, because that is something we covered it as part of the previous webinars. So it's pretty much the same, because AMCOP allows you to take any Helm charts or Helm packages, onboard it, and orchestrate it on any target cluster. It's pretty much the same, but here we will skip that step and we will focus on how to push the day in configuration changes to the CNF. Okay. So what we did, so here we see that O-RANInterface 3GPP simulator CNF, right? How did we create this? So we depended on this open source project, Network Topology Simulator. This is one of the projects that we extended, right, to create a 3GPP own interface or a simulator is what we did it. So if you look at this, you have a proper specification, but we took the release 16 is an approved by SA meeting. So this is what we took it because it's clean and it is stable version because of I guess 2019 sometime it got released actually. So we took this as a model to build our simulator. And the NTS simulator, if you see, this is a project from the Malacon. So this contains a lot of stuffs because we will not go through this. If you have any questions or anything to do with this project, you can shoot us an email offline because at the end of the presentation, we will share our contact details. We can communicate, take it offline to discuss further. But we essentially use this project to build our own simulator, netcom simulator. That's what we did it. And why? Because it comes up with the Netopia server with the systreport tools to load any YANG models. Suppose if you want to simulate a device X, and what we need to do is we just need to extend the NTS project, that's all. And then you should be able to quickly create a image and then populate it with some random data and start managing it through netconf. So that's why we picked up this project. It's pretty stable and very easy to use, I would say. And also it comes with certain capabilities required for ONAP, right? Because it comes with a WES agent built in. So this allows you to simulate certain fault events from your device. You can actually send and a WES event to a WES collector actually, because it allows you to subscribe or push those events back to the WES collector. So that's one of the reasons we wanted to bring it in. And then again, and a lot of stuffs because NTS is another, NTS allows you to even bring up multiple O-RAN devices over netconf. You can issue a netconf command to bring up multiple O-RAN devices. In case of your CI/CD pipeline, right? If you want to simulate a few thousand RAN devices, right? You could simply do this using this. So that's why we picked it up. I'm sure some of you must have looked at this project. Okay, so let's review the 3GPP own controller blueprint archive. So this is a blueprint archive I will walk you through. It's an NRM simulator, we call it. So let me just directly jump into that. So very simple blueprint I'm going to share because one can even develop very complex blueprints. But here we would like to demonstrate only the radio resource management policy, especially which is related to a network slicing profile, right? So if you want to configure certain profiles on the network slicing, and then that radio policies that you want to control it, that's what we are going to demonstrate it. So this blueprint has got two templates, one workflow, which is a config deploy, because day in, when we say day in, we should be able to push any configuration changes as soon as the O-RAN device comes online. So that's what the config deploy. And then it will execute a workflow, which is again in Kotlin based. And this is no template. I don't know how many of you are aware of CDS, but if you know the controller design studio, this is how one will create a simple workflow. So you have a workflow, and the workflow will actually execute action, which can be multiple actions, but here we only target as a one executor, one action. So this action, what is it going to do is, it is going to push and add an NRM policy. That's what it's going to do. So a device comes up with the default policies. If you want to add or edit, you could do it, but this demo is primarily focusing on adding a new NRM policy. Okay, RRM policy, let's put it that way. So RRM policy, that's what. So we have put in certain VTL files and JSON. This is pretty much it's a standard controller blueprint archive. So if you are familiar with it, and you should be able to create a simple one. We did contribute on PNF simulator, so you can actually take the PNF simulator project and start building your device management capabilities. And once we create this, what we do is we create this zip file of the entire blueprint. That's what we call it, 3GPP and ARM.zip. So this zip file is nothing but the archive of all the folders and files underneath this blueprint. That's what we are going to do. Okay, so let me go back to the slides again. So in this demo, we will not do a deep dive of this controller blueprint. Okay, if you are interested, and you can suddenly, ask any questions or the meetup chat link, or you can drop an email to understand more. We'd be more than happy to help you out, because due to the time constraint, we would like to focus on that demo right now. So what are we going to do? So this is a recorded demo, so I'll not be doing a live one. These are the steps that the video. I will stop and play the video accordingly. And if you have any questions, you can, we can make it more interactive from here, because any questions you can ask me. Maybe we can do a little bit of Q&A as well in this. So what are the steps covering this video? We'll bring up a 3GPP O-RAN simulator CNF instance or an K8S cluster. That's the first step. And we will bring up only one instance, because this is just a demo, and you could essentially connect tens and hundreds of clusters and onboard this through AMCOP UI and bring up the instance on your target K8S cluster. Could be your edge cluster, so you can actually bring it up to test certain aspects of your day and configuration changes. So we'll also demonstrate what is the default RRM policy ratio, because what we did is, when we created this own simulator, we populate the netconf models with some default random data. Okay, so you must be aware of Pyang. So using Pyang, we just default populates it in random data. We'll show you what are the default policies, and then we will use a CBA to actually add a new RRM policy as a day and configuration changes. Here we will only demonstrate the code, because AMCOP UI integration is in our roadmap, and soon you will hear an announcement from Aarna about this integrated UI capabilities. So I'm not going to cover that, but instead I'll walk you through the curl commands. It's a simple recipe. You can even use a Postman as well, but I just keep it simple for now. And then we'll push a day in configuration changes through a REST API call, and then look at the netconf server and see whether the new RRM policy got added or not. So that's a simple demo. All right. So let me go to the demo video. The step one, what we are going to do is we have already built a Helm chart for this. So this Helm chart actually emulates O-RAN device, okay, RAN device. So this is what we are going to do. So we'll use a simple Helm to push. Essentially, whatever you are doing it now, right? Whatever you're seeing it now, it can be orchestrated through AMCOP UI, because this demo specifically talks about LCM, so we kept it bare minimum. Excuse me. So here, what we did is we actually yeah. Sorry, hold on. Let me stop it. Yeah. What we did is we are actually deploying the NRM simulator that's based on a 3GPP own device Yang models. So we bring up a CNF, and then we look at the parts. So it's a very small cluster, the single node cluster using micro KDU. So here you can see the simulator instances come up. Essentially, you can run multiple of these NRM simulators as long as your service mapping is to an external port is different. So very, very useful for a CI/CD pipeline validating certain use cases. Okay, so basically we are looking at whether so So basically what we are doing here is, in this step, we are connecting to that NRM simulator and then looking at what is the default model loaded actually. So that means, I told you, right, we built the Docker image such a way that whenever it comes up, it will have certain random data populated. This is part of one of our use cases. So that's why we build the images such a way. So we will look at the RRM policy now, okay? So here, if you see that RRM policy, if you see, if you look at RRM policy ratio, right, this is a list type in the Yang definition, right? You can have list of these RRM policy ratio. By default, what we did is when the container comes up, we just randomly populate certain policies with the ID. You can see the random data for the ID. And then you can see SNSSA ID, and then you can see the policy member list, and you can even see the quota, right? So float, and then what is the min ratio, and what's the max ratio, all right. So it's a very random data that we got populated, okay? So it has got no significance in the real world, but since it's a simulator, right? Maybe if you have a real RAN device, then all these attributes may be directly connected with a single network slice, right? So maybe a slice is connected with this resource allocation. Okay, so let's go with this. So what we are going to do is, next step is we will add one more policy, because default has got 2 RRM policy ratio configured. So we'll add one more new policy into this list. That's what we are going to do. We have you can see the ID, GNN, and then RD, RRD is a random IDs. So now what we will do is, we will bring up certain things in CDS. So to achieve this, right, see, these are the initial steps one will have to do it when the CDS is deployed, right? So in this demo, we are using a very lightweight version of the CDS. So we'll show you what is the process, because the step 1 is bootstrapping. This is a one-time operation of loading the models into CDS, the default models into the CDS database. This is essentially required to bootstrap the CDS model. This will be one-time activity. We will not be doing it again and again. So we still want to walk through this. Actually, we want you to understand what is the process, but you will not go through this again, every day, because what you will do is, you will actually enrich any CBA. That is the line number 40. If you see that this is the activity which we'll do, but we just wanted to cover the entire flow of initializing the CDS and loading it. But essentially, in a real-time use case of CDS or the AMCOP LCM, you will only start from this line number 40, which is nothing but enriching your CBA. And then you distribute or store the CBA into CDS database, and then start applying your day in configuration changes. Can you hear me okay? Priya, am I okay?
Yeah. You're audible, Vivek.
Yes.
All right, thanks. Good. Thank you. So I'm going to resume that. So this is just a bootstrap process, because if someone is new to CDS, right, so they can clearly see these things are required only once when you bring up CDS. So because certain default models are bundled within CDS, so we are just loading the default model. That's what we are doing it. And then this script is to list the blueprints. So what are the blueprints we already stored in CDS? So here by default, you have only the virtual firewall CDS, because this is a default model available in Frankfurt. Okay, so that's what you see here. But in Gullian, you will see a couple of more models. I guess even virtual firewall, in VLB is added, and then and PNF, which we got contributed, right? So to the community, even that one got loaded. So this step is to basically load our data dictionaries. So data dictionary is nothing but some of the attributes that we wanted to define for our RRM policy. So that's what we are going to load. This is part of the design time. So if you look, whatever steps you are doing, these are all part of the design time activity. It's not a runtime activity. So what we are doing now is we are going to create a zip file of our NRM simulator. And this is nothing but our blueprint archive. And the next step is that we are going to enrich the blueprint. So what is the enrichment? Because when I say enrichment, right, enrichment is a process in CDS. It's a design time process, actually, activity, which enables your CDS package become self-contained. That means if you are building a CBA in Frankfurt, you should be able to port the CBA to the latest release of CDS runtime, which is a Frankfurt to Gullian release, which you can essentially do this. That's why the enrichment process is important. But here you're seeing everything in command line. From G release, they had built a very nice GUI. So you can use the CDS GUI to design all the stuffs and onboard your CBA. Enrich and onboard everything you can do it through the CDS GUI. So you see a lot of these scripts are custom built scripts actually. So these are pretty much mapped to a standard REST API calls, which are all well documented in CDS. You can refer the latest O-RAN documentation to find all these REST APIs, because so now we are going to save the enriched CBA. You can actually essentially take this CBA to port it to any version actually. So it's always forward compatible. Let's put it that way. So if you're building a CBA on a Frankfurt, then you can use the Gullian release runtime, CDS runtime, to deploy and integrate it. So here the model is getting stored. So we can check whether the models got loaded into CDS. Now you will see two, because initially we had only the vFirewall CDS, right? So now we can see the NRM simulator. That CDS archive is the blueprint got loaded. So NRM simulator 3GPP MNS is our CDS name, the blueprint name. So what we are going to do is we will tail the CDS runtime logs. That's what the next step is about. So we are going to tail it. Why? Because when we push the configuration changes, right, we would like to see the logs of CDS, what happens exactly. If you look at it, why I said very lightweight, because we are not using all the components of CDS. We are only using the blueprint processor, which is a very lightweight runtime environment. It's a single part actually. So we don't need the all other supporting ecosystem of CDS. So that's why we are tailing one of this part, which can essentially run across multiple clusters to push your configurations to the target device. So now let's look at the payload. So we are going to push certain attributes to CDS through REST API call. So let's take a look at this JSON. So if you look at it, right, this REST API, what we are doing is we are giving the target device detail. What is my PNF IP? What is my PNF netconf username, password? It could be an SSH key file, and what port it listens on. And then we have certain attributes for the adding a new policy. So adding a new policy, what is the policy ID? what is the policy max ratio, min ratio, okay, and what is the margin min ratio, margin max ratio, things like that. We set it up. These are very random values, and you can ignore the values. So what is the difference between min and max? So maybe if you are working on the RAN side of it, you may be able to understand all this. But this demo is just to understand how we can add. So essentially, we are passing the netcount device details, which is our simulator, and then adding a new policy, which has got an ID of XYZ prefix. So that's what we are going to do. So this PNF IP, all this is, we are just updating it. So IP address of our PNF is 15 subnet 193, and then we're getting the external port, which is mapped to our K8S. So that's what we are going to do. So what port we are exporting? So that's a 30830 is our external port to communicate with this CNF. So this is a node port on which it allows us to connect. So we're going to add a new policy. This is nothing but the CDS blueprint processor. We're getting this IP of this, and then we are substituting the IP in the call command. Very simple shell commands. So now we have submitted the request at the northbound of CDS. So now the CDS has pushed, and you got a response from the device. If you see that RPC response, the reply, you got it, because this is your netconf RPC. So in the netconf RPC response, you can see it as OK, which means the request has successfully reached your device. Okay, so we have pushed our RRM policy list into that. So let's look at it. Now let's log into the simulator and see whether the new policy got added or not, because our new policy ID starts with the XYZ, right? So we had initially 2 RRM policies, quotas set, and we added one more. Okay, this is the response that we got. So if you see this, this is a northbound API of CDS. So we invoked a workflow. So we have the blueprint name. Within the blueprint version 0.0.1, we actually executed a workflow, which is a config deploy. Okay, the mode is sync. What is this mode? Because one can execute a workflow in multiple different ways in CDS. And if it is through a REST API, then it's a synchronous call. So that's why the mode is sync. If you're going to execute a workflow, see the CBA workflow using DMAP event, you can do that. And even CDS supports a gRPC-based execution of workflows. So based on that, the mode varies here. That's all the difference. And you got the workflow executed, and you already got the status as well. Here you got the code 200. And then the event component got executed. All this is a standard response. And the payload, if you see that, we kept it empty because we are not returning any response. Ideally, what one can do is, you can actually query the device after the configuration change is done. And what configuration got modified, you can even include it in the config deploy response. Okay, it is possible. But in this demo, we are not demonstrating. But one can do that actually. So whatever response you get it on the SB, right, the southbound, you should be able to transparently pass it back to your northbound of CDS. Okay, so let's log into the simulator now and see whether we have the new policy added. All right, so we had this one policy. The second one already was there because RRM policy ratio is a list. Okay, and you can see our third policy, which is XYZ 11 got added. Okay, so which indicates like, through our CDS model, we are able to talk to our device actually, O-RAN device through O-RAN interface. A very simple demo. Okay, so you can essentially push certain complex configuration changes to a target device using an enhanced version of the CDS model. Okay, so this essentially shows like, this particular configuration is being pushed through. Okay, so this is pretty much what we want to cover in this demo. So we will open up the session for Q&A now. So anyone has got any questions, you can post it.
Yeah, they can either message to me. Hi, people. You guys can either message to me or you can just ask Vivek directly.
Yes, yeah, you can go ahead and ask any
Yeah,
questions.
like as we have already informed, right? We are using this platform complete for the learning experiences. So it will be nice if you can have an interactive session. Okay, Vivek, I got a question. Is this blueprint contributed back to the ONAP community?
No, we have not yet, because this has got a dependency with the 3GPP NRM simulator, right? Because this image also, it's currently hosted in our Docker local repository. Why? Because there is a licensing conflict between NTSM and NTS project, which is a network topology simulator, and 3GPP, because NTS project wants to evaluate the 3GPP license. There is some conflict which they are working out. Once that is resolved, then we will contribute this NRM simulator project changes as well as this model. So because both goes together hand in hand, because you cannot have one other one. So, but we did contribute a PNF simulator project in CDS, so you can take a look at that actually. So it's pretty much, we extended the same. So if you see that, let me show you that. If you are interested in a blueprint, you can go to this component and then model catalog, and that blueprint model, and you can see the service blueprint. And the PNF demo is contributed by us actually. So we contributed this a few months back in the community. So you can take a look at it, and then you can pretty much follow this. So this is a pretty generic one that we developed. So anybody can use this to create certain configuration changes for any target device. It's a very generic one. You can take it. Thank you, Priya.
Okay, thanks, Vivek. Okay, there is one question.
Any other questions?
Yeah,
So,
like
sorry, well, Priya, hold on. Someone is having a question.
yeah, please.
so Vivek, so when you are actually using the O-RAN simulator for policy configuration, essentially you are actually configuring the CU functionality of O-RAN.
Yes. Yes.
Okay. Okay.
So
And you have not used you have not used the O-RAN open source software, but you have actually used a simulator.
Yes.
For that. Okay.
Yes. So this is why, see, what we are doing is, see, if you look at this management and orchestration API spec of 3GPP, right? And we took the entire model and loaded it in one single simulator. So CUDU capability, everything is pretty much within this Yang models.
Oh, okay.
So if you have a split environment, maybe, some of the things you need to move it here and there, but this is essentially the entire model that we load.
Oh, all right. Okay. It's interesting, actually. So the
Okay.
complete O-RAN function is simulated through these Yang
Because,
models, right?
yes, Yang models.
And then you run it through that
Yeah.
network topology simulator, so it will generate the APIs for this configuration.
What we did is we took this model and then we extended this project, the network topology simulator. Hold on a sec. Let me just show that. We extended this project actually to build a Docker container image, because you cannot use this as it is. So what we need to do is we have to extend this project to create a Docker image, which contains all these models loaded.
Okay.
So essentially, when you create a Docker image, you bring up an instance, right? Or bring up a container, which actually emulates one real device, equivalent to a real RAN device.
Right.
So,
okay.
Yeah, you cannot simply use this NTS, but what we need is we have to extend this project. So we did it for this model, but we have not yet contributed because the contributors, the owner of this project doesn't has certain constraints about this licensing. Because if you see this O-RANInterface spec in the O-RAN, right, it has got certain licensing terms actually.
Yeah.
Okay, so they have this working group terms. It doesn't go well with this community members actually. So they have certain conflicts which they are working on, because if you look at this project license, right, it is a different one, but 3GPP follows a different one. So it's Apache 2.0, and these guys follow a separate licensing model. So this doesn't go well with both the communities. So there is some conflict. They are working on it. As soon as they approve it, then we are good to go and contribute to this. So you should be able to build everything from an NTSIM.
Okay, got it. Thanks.
Yeah, welcome.
Hi, Vivek. I have one question. You explained very nice about A1. What about E2? Because, especially I want to understand the progress, or if you are working on the near real-time rig, because this is the piece which we are more actively, I think most of the operators are looking. And the second question is just about right now, code of this, what is the status, like some field testing, some POC, or some thing on ground you have done, or if not, what is the plan for? Thank you.
So currently we have a few customer engagements going on, because they would like to simulate these hundreds and thousands of these RAN devices, and trying to onboard this device and then push a day and configuration changes. So that's why we built this simulator essentially. Okay, so we have certain engagements started, but do we really have a real-time implementation? I would say no, but we will soon have it once we have this the RAN partners, right? So whomever we are working with, if that's done, then we will be able to demonstrate the real-time implementation of this.
What about E2? You have any plan about E2 near real time, Rick? What is your thinking or progress on this?
Yes, we do, because if you look at it, right, so this is the piece that we are talking, right? So if you look at the near real time, the analytics platform comes into play, right? So you need to have certain decisions made on your analytics platforms based on certain events occurring, and then push these changes. But the model is pretty much the same, because our entire LCM operations, the southbound operations, are going to be modeled. It's a model driven. So it is, yeah, we have it in the roadmap actually.
Okay, thank you.
Welcome. So if you're working in the RAN domain, and if you're interested, please, yeah, feel free to contact us, and we can see some mutual opportunity to explore further.
Yeah, absolutely. But sure. Because just one thing, because you see most of the operators in the orchestration, they are not deploying based on the open source or themselves, right? So most of the times it's a proprietary orchestration. So I don't know normally what is happening. We are going to the ONAP community and taking this code, and then we see how the other vendor who are, this Nokia Flow One and all of the other stuff. So I don't know because of this capability how you guys are coming and how you know. So, but anyways, yeah, it's a very useful information, and we will, I
See,
think, discuss on this.
yeah. So yeah, you're right actually. So the adoption is still early, I would say, but there are a lot of companies who is already putting in a lot of effort in making this a reality. Because if you see that, right, it's one part of this 3PP is about NetConf, right? NetConf is your southbound. They also talk about the open API. Okay. So even for this, we are working on certain simulators, right? So you should be able to pretty much do through even a plain REST or through the NetConf southbound. So some of the vendors prefer this open API spec. They take this and then load it and then expose it through REST. And the the people whom we came across is basically using this Yang model to expose it through NetConf. That's what we came across.
And sorry, I'm asking because I was waiting for this type of, I could not find. Sorry, can you just summarize how many different type of models you are supporting? For example, you are supporting Yang, Tosca, NetConf, RESTConf. Is there a list or something which your orchestrator understand for, for
Okay. So if you look at it, right, so if your end-to-end service model is going to be Tosca, then within the service model, you should be able to embed a CBA, which is CBA. CBA is nothing but your controller blueprint archive. Okay. So which again is based on Tosca specification, right? So the one up CDS follows the Tosca based blueprint. If you look at it, right, this is essentially a Tosca model we are talking about. So this is for an LCM operation actually. So if you have any services, which is again going to be orchestrated through Tosca, and the LCM can be through CDS. So again, that is another Tosca that you will embed it within your end-to-end service orchestration. I don't know whether I did answer your question fully, but it is.
Yeah, I think it's clear. Yeah. Okay.
Because see, CDS, the LCM is a pretty much lightweight and it's again in model driven. So you can embed this model in your existing Tosca package as well.
Okay,
As
thank you.
as a deployment artifact, you can do that. Good question. Thanks, Sula.
So Vivek, I mean, did you actually do Tosca implementation for this configuration, or you use the JSON implementation of that?
Okay, so let me clarify this because CDS follows a Tosca defined on a JSON spec. Okay, it is not the full Tosca spec actually. So what they did is they took the Tosca specification and then carved out a very lightweight model actually. So let me show you that. So lightweight Tosca model, which is nothing but the standard type. So they took this and then took the artifact type, data type, node type, relationship type. Okay, this is what they defined. And one can actually extend it. See, if you look at that artifact type, right, you can say that I'm going to execute an Ansible script, okay, for my LCM operation, which is model, which is very lightweight. If you want to extend it to meet some of your own, device or XNF related stuff, which is not covered, you can pretty much extend it. But they took a very light version of the entire Tosca model. It's not the entire Tosca model, but they picked up a very lightweight model, which is very much applicable for any NF or PNF LCM operations. You can extend it at runtime.
And what about, what about the telemetry and this analytics, right? Because you showed in the diagram REST, but the REST is not the real time. Either you have to use the BPF, eBPF, or the gRPC, this type of scenario.
Right.
So how you are solving this issue, I don't understand.
So let me correct this. Actually, I should have updated this one. So this will correct you actually. If you look at it, right, the analytics platform is essentially, it's going to be augmenting all your time series data. Okay, you can call it as a DCAE plus policy put together. Okay, so if your device is sending SNMP events, which gets transformed into an WES event, pushed into this analytics platform, and then if there is a policy which checks for a threshold, if it exceeds or goes down, and then it can actually asynchronously trigger run gRPC. Okay, so So this is the one actually. So all these three types of interfaces are supported, which I explained it here. But so essentially, one can trigger those analytics events through any of these interfaces. REST is one of the interfaces that we demonstrated, but CDS can receive the NB calls, the northbound calls through gRPC or Kafka. Even they support NAT actually.
Yeah, okay, it's clear. Thank you.
Yeah, it's not only that Kafka, so it supports the NAT as well actually. I guess there are few more things of they supported it. If you have any messaging system, you should be able to directly plug it in. Okay, so maybe I can show that diagram. Just let me explain that. So that can give you the idea. So yeah, maybe this is someone we can look at it. Hold on, let me open that. So CDS has got a lot of these northbound APIs. If you're especially interested in certain things, so I can show you this. So if you look at this user guide, we did contribute back to this community documentation. So this is the diagram I was talking actually. See, it supports the NATs as well. So Hazelcast, they support it. It is again an in-memory-based database systems. Okay, if you want to asynchronously send in certain events. So all these types of interactions it supports: Kafka, DMAP, gRPC, NATs, and Hazelcast.
Yeah, it's clear. Thank you. Very clear.
All right. Thanks. Any other questions?
Yes, may I ask a less technical question?
Yes, please.
Thank you for the presentation. I'm calling in from Singapore. I'm really just interested in understanding how does the role of the traditional vendors of network equipment, like Nokia, Huawei, and so on, with these innovations of Open RAN and so on. Is there now a need for such entities? What actually changes now when these things are deployed with open source things?
Yeah. Yeah, it certainly makes the innovation possible. But Sriram, do you want to answer that question? Maybe.
Yeah, sure. I think it's more of a business question. So I think they will coexist. Obviously things are not going to change overnight, right? So they will coexist. But certainly all these open standards and disaggregation opened up opportunities for a lot of new players, especially the startups, right? So that's the change that we see. But that doesn't mean that the existing players will will not continue, right? I mean, they're also contributors into this, and at the same time, the existing legacy products will continue. So we don't see any change in that.
So I'm sorry, just want to clarify. So is that because they're already there, so obviously they will continue to contribute, or do you mean that the current infrastructure is not feasible on its own without the traditional models? Or is it just a choice, or is it that technically it's not feasible without old architecture?
No, I think obviously technically it is feasible. It's just that it's going to take time, right, to mature and for things to come to the same level of maturity as the existing products. So,
thank you very much.
Sure.
Thanks, Chris. Thank you.
Yeah, Vivek, I have one more question in my chat.
Yep, please.
How are we collaborating with O-RANalliances and TIP's Open RAN initiative on the standard they are defining?
Yes, yes. I guess we have started certain engagements. Sriram, can you add on to that?
Yeah. I think we've just started contributing, and I wouldn't say that we have actually made a lot of progress, but we've started the process.
Yeah. See, to begin with, right, see this, the NT simulator, right? This is one of the work actually, we took it from the O-RAN. This is exactly the same spec what we are talking about, that own interface, right? So we took it, we integrated it with another open source project, but this is something we yet to contribute that, because of certain licensing restrictions.
Vivek, can you please share this URL in the chat, please? I just want to have a look on this.
Oh, yes, I can do that. Okay, so hold on a sec. Yeah, this is a O-RAN wiki page. You can take a look at it. This is essentially what we have begun. We will soon, right, once the licensing stuffs are resolved, and we will contribute whatever work we did it. So in a way we started, but yeah, it's just that matter of time that, we will start seeing our contributions on this.
Thank you, Vivek.
Thanks, Priya.
Okay, one more question has popped up. I mean, so many questions for you today.
Yeah.
Is the chart available for all?
Can you come again?
Is the ham chart available for all?
So yeah, we can. Yeah, if you need it, please just do keep in touch with us. The only thing is, currently the Docker image is only hosted on our Docker registry. So if you want any special access, yeah, let us know. We can certainly share that. Do contact Shriram or me, and we can take it offline. But Helm chart we have not yet published, because yeah, this is what I was saying, right? It's all part of the same work. So we need to contribute everything as one piece to the community.
Okay. Thanks, Vivek.
Thanks, Priya. Any other questions? So
Yeah,
this is
I'm just checking it.
Yeah, please. So think about it, right? And if you want to simulate and then trying to integrate either one app or any other platform to onboard a few thousand or few lakh devices, right? These simulators come in handy, actually, because it has got everything what you need to actually, understand the scale at which your, the orchestrator platform can handle it, right? So think about this analytics platform, which can actually manage a few lakh RAN devices, right? You cannot go to the field and test it. Rather, you can test it using the simulators to push certain random events to take certain actions, or pushing through the CDS, right? To get a closed loop or a near real time changes validated. So that's why we began with this analytics. Sorry, the simulator part of it. Okay. So any other questions? Any specific use case someone wants to discuss here? We are pretty open. We can discuss it, or you can reach out to us or email. All right. So we'll wait for a minute and then we can close this.
Yes, we can.
Priya?
Yeah, I also have to tell them about the future events. So we will wait for a minute and then we can.
Yeah, let me stop sharing. So I'll still be open, but anybody can ask question. I'll stop sharing. Yeah.
Yes.
Yeah.
So these are our future events, which is coming up on 25th Jan, 8th Feb, and 22nd Feb. We will meet again. Please sign up, as it's going to be a very good learning experience for all of us.
Right.
And if you have any queries, please reach out to us.
Okay, I guess we are coming to the end. Thank you, everyone, and
Thanks,
really
Vivek.
appreciate the time. And do keep in touch with us if you need any further details about this webinar. Thanks, Priya, for organizing it. So
Yeah. Thank you so much, Vivek, and thank you everyone